In this problem, we are given the model that gives us the number of bicycles that can be sold in a month. That is, n of x is the model which tells us how many bicycles can be sold in a month, where x represents the price of each bicycle. And we have to determine the price the company charges to have the largest revenue. So this is one of the optimization type of problems wherein we have to apply a certain strategy to determine the price the company charges to have the largest revenue. So here I have outlined a few strategy for solving the optimization type of problems. So first we have to draw a picture. As far as this problem is concerned, we will not have to draw a picture because we usually draw a picture when the problem involves like finding the maximum area or the largest volume like that. So we can skip this step only for this problem. Then we have to identify the quantity that is to be maximized or minimized and find a formula for it. That is, we have to identify the objective function. So for this problem, clearly we have to find the largest revenue, that is the price at which the company charges to have the largest revenue. So clearly the largest revenue or the revenue is our objective function. So let's see if we have a formula for the revenue function. We don't have as of now, so we can create the revenue function. So I'm going to create the revenue function. Let's say the revenue function is denoted by R of x. So this is given as the price times the number of cycles sold. So we can write down this as x times of n of x, which means we can simplify this. So R of x is the revenue function. This is equal to x times of, I'm going to replace n of x as given in this question. That is 144 minus 1 over 10,000 x squared. And x is greater than 300 and less than 1200. So this is the revenue function, which means we have identified the objective function. Now let's move to the next constraint, that is our next strategy. So we done with the second. The third is using given constraint, rewrite the objective function as a function of only one variable. So which we already did. So in fact we have completed the third step. And finally we have to use the calculus method to maximize or minimize the objective function. So let's do the step 4 now. We are on step 4. So in this step, we have to first determine the critical point of the objective function. That is, according to calculus, the maximum or the minimum value usually occurs at the critical point. So here to determine the critical points of objective function. That is a critical point of R of x, the revenue function. For that, we have to use the first derivative. So let me do the first derivative of this revenue function R of x. The first derivative of R of x is R prime of x. So this is equal to, in fact, just before this step, we should distribute the x. So first, let me do that. I'm going to simplify. If I distribute the x to these two terms, I'll be getting 144 times of x minus 1 by 10,000 x squared times of x is x cube. So this is the simplified R of x. Now let's find the derivative. So we will get R prime of x. This is equal to 144 is a constant and derivative of x is 1 minus 1 over 10,000. Then the derivative of x cube is 3x squared using the power rule. So this is what we get. Now we have to set this up equal to 0 so that we can determine the critical point. So set R of R prime of x equal to 0, which means we can replace R prime of x equal to 0 in this equation. So R prime of x equals 0. We get 144 minus 1 over 10,000 times of 3x squared. Now let's solve for x from this equation. I'm going to transpose this term to this side, that is this entire quantity. This is in terms of negative, and when it is transposed to the left side, it becomes a positive quantity. So I'm going to write down this as 3x squared over 10,000. This is equal to 144. Now I multiply both sides by 10,000. So I get 3x squared equals 144 times of 10,000. We have to divide by 3 now. So let's divide by 3 so that we get only x squared on the side. So here we have 144 times of 10,000 over 3. And to determine the x, we have to take the square root on both sides. So we do the square root, and we can plug this into the calculator. And when we do that, we get the values of x as plus minus 692.82. Since x is in price, this is rounded to nearest essence, and we already know that the x can be only between 300 and 12,000. So this cannot be negative. So I'm going to ignore the negative value and consider only the positive value. That is x equals 692.82. So this is our critical point. Now using this critical point, we have to verify that at this point the revenue is maximum. So for that we have to use the second derivative of the objective function. That is, we have to find the r double prime of x. So first let me copy the r prime of x. We have r prime of x, that is the derivative of the revenue function, is 144. It is 144 minus 1 by 10,000 times of 3x squared. So this can be simplified as 144 minus 3 over 10,000 x squared. Let's find the second derivative of this function. So I find the second derivative or the derivative on both sides. So derivative of a constant is 0. So this becomes 0 minus this is a constant. So I keep the constant as it is, 3 by 10,000, and find the derivative of x squared. Derivative of x squared is 2x. So basically we get this. Now we can clearly see that this reduces to negative 6x in the numerator divided by 10,000, or in fact we can reduce this to negative 3x by 5,000. So this is our r prime of x, that is the second derivative of x. Now we take this critical point, that is we plug in this critical point x equal to 692.82 into the second derivative, that is the objective function, and determine if it gives a positive or negative value. So if r double prime of x, if it is greater than 0, then the critical point is a minimum value. It is a minimum value. However, if it is less than 0, then it is a maximum value. This is according to the second derivative test. We follow this. So let's plug in x equal to 692 point into this function. That is, we will have our double prime of 692.82. Here we will not have to calculate the complete or the exact value. We just need to understand the sign of it. So we put negative 3 times of, I replace x by 692.82 over 5,000. So if you multiply these two quantities, this will be a negative, and divide by a positive quantity. So finally, this will be a negative quantity. So this is negative, which is less than 0. So clearly, this point is a maximum. So we have just verified that at this point, that is at x equals 692.82, the revenue is largest. Revenue is largest. So therefore, we say that the company has to charge the price of each bicycle as $692.82 to get the largest revenue. So this answers this question.